But this is a story about Namely. We're an HR, payroll, and benefits company, software as a service. We move about $1 billion in payroll monthly. We have around 100 engineering employees, and we are moving to microservices for the past couple of years. It's a very, very slow process. So our infrastructure, we are running on Kubernetes 1.9. We have been operating Kubernetes in production for 2.5 years, so we're pretty avid with the technology. Kubernetes 1.9 for a little over a year now, and we're slowly going to 1.12. Jenkins for tests, Spinnaker using the V2 provider. We did recently update from V1. We're using Amazon for all of our infrastructure for Kubernetes environments, Istio 1.0.2, gRPC, and almost every single language available. So if you can't tell, we are very bleeding edge. We've had a lot of problems with all these technologies, and one of the things to solve these problems is just to build your own tools. So a little bit of background, we did have 2 services, and then now we have too many. So we had a Rails monolith and a .NET monolith. And now what we have is we have 3 dozen and slowly but surely climbing services in our architecture. Mostly all new services are being written in Go or .NET Core, actually, .NET Core 2.1. So we also found ourselves with the improper tooling when we started doing this transition. If anyone here has gone to microservices, if you don't have the right tooling, it's just more painful than just latching onto your monolith, right? So this causes a lot of problems when you don't have these right tools to deploy, because now you have this, okay, I have 36 problems now instead of 2. So SRE was responsible for all deploys. So I'm on the SRE team at Namely. So you can imagine one of my jobs was to literally run kubectl apply locally from my machine to deploy code to our clusters. That's not a good scenario, right? So not exactly the right way to do things. And the other problem with this is you don't really have a standard on how things deploy when and who. It's kind of an interesting problem when you don't have a deployment tool like Spinnaker. So how do you improve that? That's a really daunting thing. Okay, you can't just say Spinnaker, right? That's not a solution. So our initial solution was deploy from Jenkins. Why not? It works, has plugins for it. So here was our great idea. We'll write a kube-deploy.sh file, and we'll add it to every single project that deploys, and then we'll modify the Jenkins file to run this file. We'll open 30+ pull requests to do this, because we don't want to just give it to every project on the Jenkins node. And boom, we have continuous deployment, right? Here's part of it. Yeah. This was not great. This was running from Jenkins. We had to give all of our Jenkins nodes Kubernetes credentials. You can see all types of fun stuff in here where it's waiting for the deploy to update. It's actually doing seds and awks just to figure out what the current desired state is. Not good technology. So it was about a few weeks into this. At this moment, we knew we had effed up. It was bad. Only took a couple of weeks to realize this. And then we started to introduce Spinnaker. So I have a coworker, his name is Shrey, couldn't make it, and he said, yeah, I can install it in 3 weeks. Hands free. I don't believe you. Why don't I believe you? So I think open source is 1/3 of the problem. To any business problem, you're never going to be able to install open source and boom, solve a business problem. It just doesn't happen that way. So installing and configuring tools like Spinnaker is actually the easy part. It might suck in the moment, but that's the easiest part that you're going to deal with when installing these tools. Educating, documenting, productionalizing what happens when it goes down, who's on call. All of that is the hard part. That's the 2 and 3rd part of this. So we at Namely, we use a design doc process, if you're familiar with Google does this. And basically, we spend a lot of time sharpening the axe before we try to chop down the tree. So our chief architect, this is he just says this. We bring up ideas, and he's like, write a design doc. That's all he says. So we had to come up with rules and requirements. What are we trying to achieve, and how are we going to achieve it? So pipeline configurations must have a source of truth that is versioned in Git. If you're using Spinnaker right now, this doesn't exist. Pipelines must automatically update in Spinnaker when changes are pushed to GitHub. Also something that did not exist. Releases must be recorded for all environments for every single project. So these were pretty, we're looking at Spinnaker, we're looking for these requirements, and they don't exist. Spinnaker just doesn't support these things out of the box in the way that we wanted to use it. So part one, pipeline config. So what is a pipeline? If you're using Spinnaker, you probably know this, but we did want to use Spinnaker pipelines for all of our deployments. No ifs, ands, or buts. That had to be the case. However, Spinnaker didn't have a tool for codifying what a pipeline is. That sucks because we don't want our engineers managing their pipelines from the UI. It's very error prone. You can't create standards. Also, you're going to have drift. If you have one application over here, another one over here, all of a sudden, 2 months later, this one's deploying completely differently than this one, and nobody knows what's going on. So also not ideal. So our decision was to actually just build this missing tool. So where to start? Spinnaker has a really neat feature of the pipeline UI where you can actually click Edit as JSON, and you can see everything that Spinnaker actually stores for its pipeline config. It's a gigantic JSON blob, but you can go ahead and just look at it, which is great. So we actually configured pipelines by hand first, and then what we did is we would click Edit as JSON, and we would get a giant blob of JSON for a configured project. So what we did from there is we would actually create concrete Go structs to represent this JSON. So that was kind of the first step. How can we represent a pipeline in Go structs? And this tool actually became K8's Pipeliner. So K8's Pipeliner has a ton of Go structs in it that actually represent what a Spinnaker pipeline is. And it doesn't even scratch the surface of what Spinnaker can do. So this project is open source. It's on, I should probably throw a link on here at some point. It is at github.com/namely/K8s-pipeliner. And you can actually use it for deploying to Kubernetes and codifying your pipelines. Great. But the reason that creating these structs is valuable is because what you can do is now you can start to attach behavior beyond the pipeline. What if you want to inject things? What if you want to actually do linting on your pipelines? How do you lint that the names are lowercase dasherized? You don't really have that option until you have something like this. So now what we just need is, now that we can represent what a pipeline is to Spinnaker, we need to create something that represents a pipeline to Namely. So we need a pipeline config kind of definition. So we had to make this up ourselves. So it does include a set of pipeline config objects. And these values are what compose a pipeline.yaml file. And this is what we use at Namely for every single project. You actually define your flow for your pipeline in this YAML file. So it looks like this. You can actually see that we have a name, application, all of the triggers that you may want to have, stages, image descriptions, which is we use Docker for everything. So we're describing what an image might look like, et cetera, notifications, parameters, and there is a typo in there, but it still works, I promise. Okay, so that's great, and it actually allows us to do this. That Go struct means that we can create a pipeline.yaml file that looks just like this. So you can see it's the name of the pipeline, the application that it attaches to, some of the triggers. So we actually support Jenkins and webhook triggers at Namely. And then image descriptions, basically describing what the Docker image is that we have to actually shove into this pipeline at the end. And then all of your stages. So migrating a container, deploying a container, all of those fun pieces of a Kubernetes pipeline that we do at Namely. So one of the key things here is that we wanted to define pipeline flow, not specifics. And what I mean by that is our pipeline is just deploying artifacts. It's deploying containers and Kubernetes manifests. But the flow of that is really what we care about. We care that we want to migrate a database first, and then we want to deploy code, and then we want to notify somebody that this happened. That's the flow of a pipeline. That's what Spinnaker is really good at doing. But what we don't want to define is what is getting deployed. So for example, we don't want to define all of the pod-specific container things. So like the registry that it's coming from, environment variables, the command that it needs to run, all of those pieces. That's the what is being deployed. So we don't want to actually define that in our pipeline.yaml. Instead, what we do is we actually reference just Kubernetes manifests out of the box. So down here at the very bottom, you can see that we're actually just referencing a Kubernetes manifest file. And this is awesome because if you're running on Kubernetes right now and you want to move to Spinnaker, you can export this file as YAML, just do a get deploy -o YAML. And now you can put it in a pipeline.yaml file and you can deploy it with Spinnaker. That's awesome. So that was what we did. We actually just brought down all of these files and referenced them in our tool. And then what we can do is we can actually render a pipeline using just that manifest. One problem, though. Who here is using the Kubernetes v1 provider? Few of us. Has anyone switched to the v2 provider? Is anyone using that one? So the people that just raised their hands are much happier than the people that previously raised their hands. And the reason is because Spinnaker, I don't know the history here. I'm not on the team. But it had its own flavor of what a Kubernetes object is as JSON. So that meant that we had to basically recreate Kubernetes objects in Ghost structs because they're slightly different for the v1 provider than they are in the actual v2 provider, because v2 just uses the actual spec. And that caused a lot of problems for us because we would discover that, oh, we wanted to use like a different type of container env. So we actually had to recreate all of these Ghost structs for every part of a container that we can deploy via Spinnaker. And then we had a problem like, oh, we don't have pod security context. So we just had to do this, and we just gave up on trying to like search and destroy, and anytime we found it, we would just open a new pull request. So if you look at K8's pipeliner, it looks like it had a lot of pull requests, like a lot of activity. Half of them are just this. It's because we were finding problems that it just didn't support something like host path. So while that process was a long time, took like 2 months to get to a point where we actually had the proper JSON, we did eventually get what we want. So you can see up here running K8's pipeliner, create test pipeline, piping in a JQ to get pretty format. And you can actually see that this is Spinnaker JSON for v2, but I didn't have a better screenshot. So we get Spinnaker pipeline JSON. That's great, because now what we can do is, remember that edit as JSON, we can actually just go back to that UI, click edit as JSON, and we have a new pipeline. So, and then boom, I have a pipeline. I have, I don't know, it's like 7 stages in there. That's a pipeline for int staging and production deploys from a like 100-line long YAML file. So pretty sweet, right? Really easy to create a pipeline from just manifest files that you already probably have in Kubernetes. So what are the wins here? Never managed via the UI, with the exception of going in and clicking edit as JSON. All of our pipeline.yaml files are in Git now, so we're version control. That means that we can actually revert pipelines. If you make a change to the Spinnaker pipeline via the UI and you break something, good luck. But if you are using this kind of technique, you can actually revert the commit, regenerate the pipeline JSON, and you're good to go. So it reverts to, and then a track record of who changed this as well. Another thing that Spinnaker doesn't do very well is an audit log of who's changing pipelines. So now, since this is in Git, we know who changed it and everything. Okay, so alternatives considered. We could have configured every project manually and rolled that out without version control. We could, or with S3, it sounds like. We could also let teams own their own process. But the long-term spend of that is pretty enormous because you're configuring the UI is tedious and pretty error-prone in a lot of scenarios. Linear scale of time spent as we add more applications to our project, so not ideal. So one of the things that I really like this quote from Ken Beck was, make the change easy and then make the easy change. So we could have just said, here's Spinnaker, go and configure everything, but instead, we said, let's spend the time up front. Let's make this an easy transition to go to Kubernetes and on Spinnaker. Let's make it easy to just do that one step, and we'll do all the legwork up front. And that's what Kubernetes Pipeliner actually did for us. So by creating these concrete types, we can represent a Spinnaker pipeline very easily. And then what we can do is move on to other things now that we have these defined types and processes to do other really cool things. Part 2, automatic pipeline updates. So avoiding the UI as a service. These are my personal opinions. I love Spinnaker. We use it for every project. But for the UX for managing pipelines is a little clunky, in my opinion. But it's for a good reason. UI UX is really hard to do when something can do so much. A good example is, anyone here use Amazon Web Services? I mean, it's just, the UI it's kind of crazy, right? Because it can just do so much. It's so powerful. And that's a great problem to have. But for us, we didn't really want to deal with this problem. So our ideal flow then becomes, instead of pasting JSON into a text field, we want this to actually be automatic. So whenever a merge is actually performed on GitHub, what we want to do is we want to update the relevant Spinnaker pipeline for the pipeline.yaml that exists in that project. So we clone the project down, run a KS pipeliner automatically, and then paste it to Spinnaker's Gate API. So we have a project called Estuary. So here's the flow. Git webhook goes to Estuary. Estuary does a git clone, runs KS pipeliner, and then posts it to Spinnaker Gate. So this is something that we've built internally. Preemptively, it's not open source right now. I started looking at open sourcing it last night, but there's a lot of things that I would embarrass myself, so we're not gonna do that yet. But Estuary is pretty simple. It's a HTTP server written in Go, receives GitHub webhooks, builds pipeline config, and then updates Spinnaker. So the nice thing, looking back, right, this KS pipeliner tool, because we have this tool that allows us to codify pipelines, we can actually just import that because we wrote it in Go. So now we have this great package, import it into our Estuary Go server, and now we can build pipelines pretty easily. And then the other really nice thing about this as well is that every project at Namely gets config automatically without adding it to their project. Because we have the ability to actually clone this and run KS pipeliner, we can actually modify the pipeline in memory first and inject things like a global config map variable, something like a secret reference that doesn't exist in your manifest, but we know you're going to need it based on like some annotation in your project. Really, really cool things that we can get away with. One of the problems, though, is we try to configure Gate to authenticate. We've configured Gate to authenticate via GitHub and an X509 certificate. And I say Gate, really, what I mean is just Spinnaker. So using the X509 cert, we can actually send these post requests to Spinnaker without a login, which is great. And we can update from Estuary. But what this request actually looked like, we didn't really know. So Spinnaker has a Swagger file for its API. We did just find it easier to just look at the requests, though. Because it is an Angular app, what we did is we went into the UI and we updated the config. We opened up Chrome Developer Tools, hit submit, and we just copied what that request looked like. It was a little bit easier for us. The Swagger thing, there's a website that was hosting the Swagger file, but it seemed a little broken, so this is the approach that we took. But once we figured it out, we can actually easily update the pipeline. So here's what we're going to see. I'm not a fan of live demos. They never go well for me. So you're going to see a simple pipeline.yaml file get updated. You're going to see, and then Estuary in the background is actually going to receive a GitHub webhook, and then Estuary is actually going to clone and update this pipeline automatically. Release logs. So this is something that we really wanted. I'm sure that we could do this via S3 as well, but we had a few other requirements that we wanted on our release logs. So what is a release log? Very simple, structured entry of what was deployed when, and maybe some other simple metadata, maybe a JIRA ticket that was associated with it. Stored forever, most recent first in our case, can be used for identifying what release broke what, which is something that anytime we deploy, sometimes something might break. So knowing what was just deployed is great. Metrics, so we can actually query, when do we deploy and when do things break? Who deploys the most? Give out maybe an Amazon gift card or something like that. And release managers love it, so you gotta have it. So how do you create these logs? So Spinnaker has a module called Echo that can send webhook requests on task events. So what we've done is we've configured Echo to send webhooks to our release management software. And release management service parses the webhook and creates log entries when pipeline stages are complete. So this is something that we've done. So Spinnaker Echo to the release management service and then storage. So what should we use for storage? Google Sheets. Oh yeah. No, I'm not kidding. Oh yeah. So here's what we do. You can see in here it is a little bit small up there, sorry. But what the release management service does is it's actually going to read some of the Spinnaker trigger metadata. So we actually send like the current commit, the project and everything like that. And then what the release management service does is hits all these different APIs and will actually create like the GitHub diff link maybe a Jira ticket, some summary, XYZ. And then everything just gets dumped into this. And you can see at the very bottom down there, there's int, stage, and production. So if you want to know which environment, just switch the sheet that you're looking at. And this actually works pretty well. So how do you even get started with this payload? So this was something that we, and maybe this is another oversight on our point, but we could not really find what this payload looked like. There's like one small example, but it doesn't cover the whole thing. So little did we know that also that these payloads are enormous. They are gigantic. So we tried using a couple services. We used request bin, and request bin was truncating. It's like, hell no, we can't use this. And then request bin shut down probably because we sent all of our Spinnaker events to it. And so what we ended up doing, we found this awesome one. We actually found webhook.site. Really, really cool. I recommend if you're building something with webhooks, this is a really, really awesome tool. And it was able to handle these payloads, so that was actually the biggest benefit of this. So you just go to webhook.site, it creates a URL, and you can see at the top right there, you get a nice little UUID URL. So then what we did is we just took that URL that webhook site gave us, we modified the echo config to send all of our payloads to it, and then kick off a pipeline, preferably something without sensitive data because we don't own webhook.site, we don't know. We just kind of care about just seeing the structure. So don't kick off a pipeline that's deploying secrets or something like that. And then we just watched webhook site fill up. So I don't have a video for this, but you can just imagine webhook site getting 12 requests in a split second. The amount of, don't write something that's going to receive echo webhooks that's not performant. It sends a lot of webhooks very quickly, and they're very big. So naturally, release management service was written in Go for us. But once we had this payload that we looked at webhook.site, we were able to kind of create these structs. So following the same pattern that we did for Kate's pipeline and really just doing some introspection of what Spinnaker is really doing under the hood with its JSON payloads. So we can see here Spinnaker event, details content, event ID. And this is a very, very, very bare bones interpretation of a Spinnaker event. It does a lot more, but for our purposes, this is all we really needed. So when we do release Google Sheets as a service, maybe we can ask for some contributions on this as well. But it does allow us to do some cool things. We're able to actually send all of that data to Google Sheets. And so thank you so much for everyone for coming, and have a nice day.